Hello everyone, welcome to this channel, and in this video I'll make you understand Venturimeter. We'll understand a Venturimeter from ncert Physics class 11. This is chapter 10 of class 10 class 11 Physics, Mechanical Properties of Fluid. First of all, let's understand what is a Venturimeter. It is a device to measure the flow speed of incompressible fluid. Okay, so how is this device look? This device looks just like this. Okay, you see there is a this is a device, and in this, just a second. mm, yeah, so you see here is a constriction. This is a kind of a pipe with a variant cross section. Here the constriction, the area is very small here. Okay, and you see the velocity, we will apply the principle of continuity. This region will be have larger area, so the velocity will be low here. This is smaller area, the velocity will increase here. Okay, and we'll put the venturimeter on. Okay, there is a pipe in which the fluid is flowing. We have to measure the velocity of the fluid in through the pipe, so we'll just insert the venturimeter, okay, in between the pipe. Okay, and now what we can obtain, we can obtain the yes, from this area we know area we can measure, and velocity we will measure. Velocity at this point we will measure, and what we'll do, we'll take the help of a manometer. So manometer is a device which is used to measure the pressure difference. Okay, so pressure difference between these 2 points. Okay, so what will happen, we'll just put this is u-shaped tube. Okay, and you see the pressure will be different here. Okay, and the pressure will be different at this point. Okay, so because of this pressure difference, there will be a rise in the this mercury on this side, and it will dip here. Okay, this difference in the height, okay, we can measure, and because of that we can measure the pressure difference. So pressure difference will be measured because of manometer will help us measure the pressure difference. We will apply the Bernoulli's principle. Now we know the pressure difference, the height for this region and this region always is almost same. So what is a Bernoulli's principle? The pressure energy plus kinetic energy per unit volume plus potential per unit volume is a constant. Pressure we have measured, pressure energy, P part we have measured, potential energy is almost same. There will be it will not be, we will just ignore it. The change in kinetic energy, and change in kinetic energy we will we will measure then with the formula half, yeah, rho v1 v2 v1 v2 minus v1 square is a constant. We can measure that. Okay, so let's understand it completely from ncert. Okay, now see, Venturimeter is a device to measure the flow of speed of an incompressible fluid. It consists of a tube with a broad diameter and a small constriction at the middle as shown. Okay, it has a, as I told you, broad diameter and a small constriction, very small area. Okay, a manometer is in the form of a U-tube, is also attached to it with one arm at broad end neck point, one arm at the broad neck point you see, and one arm at the constriction. Okay. The manometer contains a liquid of density rho m. It can be mercury, it can be any other liquid. It has a density rho m. The speed v1 of the liquid flowing through the tube at the broad neck area is to be measured. Okay, we have to measure the velocity at this, okay, which is in the tube, in the pipe. Okay, that we have attached this venturimeter in between the pipe. Okay, so by equation of continuity, v1 a1 is equal to v2 a2. Okay, so the velocity at v2, this region v2 will be what, how much velocity v2 will be? By equation it will simply be a1 upon v upon small a. This is and v in times v1. It was like this, v2 a is equal to v2 small a is equal to v1 a. So from this we have obtained this. Now apply the Bernoulli's principle, Bernoulli equation, pressure energy per unit volume, okay, plus kinetic energy per unit volume. Potential we have ignored because there is not much difference, negligible difference in the height of the two parts, so it can be ignored. Okay, half rho v1 square plus p2 half rho v2 square, and v2 we have replaced by a upon capital A upon a v1, so it will be a upon a square v1 square. P2 will shift this side, rather we will shift p1 this side, so what, and this to this side, so what we'll get, p1 minus p2 is equal to half rho v1 square, and we'll just take out half rho v1 common, then what we'll obtain inside the bracket, it will be capital A upon A square minus A. P1 minus P2, as I told you, we can take the help of manometer and we can measure the pressure difference, because there is a difference in pressure. The fluid will be different at different height, and this height we can measure, and through the P is equal to what? The pressure difference will be measured with the help of this formula rho gh. Density of the fluid we know, height we can calculate, and we know the pressure difference. So this part we can calculate P1 minus P2 with the help of manometer. This pressure difference causes the fluid in U-tube connected at narrow neck to rise in comparison to the other arm. The difference in height measure the pressure difference. Okay, so this we know. Area we are known. The manometer can be measured. The Venturimeter can be measured. Rho we already know of the fluid, and V1 we can calculate from this. Okay, so V1 can be calculated. The velocity can be. This is how we calculate the pressure, the velocity through a Venturimeter. Okay, and yeah, so the speed of the fluid, so this pressure difference will be equal to how much? Rho gh. Okay, so speed at the wide neck is given by, we'll just equate it. 2 will be taken this side, then rho v1 will be taken downward. Okay, and v1 will be here only, and it will taken, we'll just cross multiply we have to do it, then we have to take square root, and we will obtain this extent for the velocity.